Hi everyone. So I'm back for business. So again, we're going to be looking at trigonometry, but this time we're going to be looking at rearranging the trigonometric formulae. So SOH, how to rearrange SOH CAH TOA. So sine equals opposite over hypotenuse, etc., etc. Okay, but let's go back to this example here. So remember, we said that we found out that the opposite side was 10, didn't we? That the hypotenuse was just double the opposite. Well, let's see another way of approaching this. So again, when we do trigonometry, we should always label the sides. So we've got the 30-degree angle here. I'm going to label this my opposite, hypotenuse and the opposite. Now what ratio deals with opposite and hypotenuse? Well, it's going to be sine, or SOH. So we need to write out our formula. We know that sine 30 degrees equals to opposite over hypotenuse equals to x over 20, and I'm just going to put the sine 30 just to show you that it's equal to. Now, what's sine 30 the same as? We discussed it in the previous session. If you type into your calculator, you're going to get 0.5 equals to x over 20. Okay, so now we have to figure out what x is. So I'm just going to put a line here. So I'm going to put step 1, 2, 3. And if I've got x over 20 equals 0.5, I always swap them around because it just makes it easier. How do you think I get to x? Well, I times it by 20, both sides by 20, and I should get x equals 10. So I know that I've done it correctly because my opposite side is less than my hypotenuse. Remember, hypotenuse is the longest side in a triangle. What I wanted to point out as well is if you're struggling to rearrange formulae, here's another way to think about it. If I have 6 over 2 equals 3, and I'm trying to figure out the 6 is the same as 3 times 2. Okay? I don't believe in these triangles. I don't know, in physics they always tell you, oh, use these funny triangles. I don't really like doing that, but it's fairly simple anyway. Okay, let's try a more difficult example. Okay, so this time we're going to find out what the value of x is here. So again, I'm going to label my side, so hypotenuse, that's the easiest one. We've got our angle here. Actually, I'm just going to call it C, just for simplicity. And we've got, what's the relationship between angle and this? It's going to be the opposite. So what ratio deals with opposite and hypotenuse? Again, it's sine. So I'm going to write out my formula. So I always start off with writing out the basic formula. Opposite over hypotenuse. I'm going to put in what I know. So sine 50 equals to opposite over hypotenuse. So my opposite is going to be x, and my hypotenuse is going to be 30. I'm going to swap them over again. What does that give me? It's going to give me 30 sine 50. Or that's another way of writing for sine 50 times by 30. So times by 30 times by 30. And let's see what we get when we type it in. So I'm leaving the calculator to the very last minute. because and we should get 23.0 centimeters to 1 dp. And I know that I've done it correctly because it's less than what hypotenuse. Okay. So I'm also going to write 30 sine 50 here, just to show you that we might be able to figure out a relationship, but that will come later. That'll be another one that we go through. Let's try this one. So this time we have a cosine function, and I mean this time we're going to figure out what the value of x is. I sort of gave myself away, didn't I? So again, we're going to label the sides. So we have hypotenuse and adjacent. Now I've been kind and told you at the top that it's cosine, but you need to actually label the sides to work it out yourself. And you'll do that if you're doing questions. So we're working out the value of x. Now again, we write out our formula. So cosine of an angle, in this case 70, is equal to adjacent over hypotenuse. So in other words, adjacent over hypotenuse. So again, we have cos 70 equals to x over 12, and x over 12 equals to cos 70. Again, what do we do to both sides? We multiply them by 12. And we get x is equal to 12 cos 70. And what does that give us? Well, I'm going to type it into my calculator. I'm going to see what I get. 12 cos 70, I'm going to get 4.1. So that, again, that seems reasonable because it's less than 12. You know you've done it wrong. If I was getting 13.5, then I'd probably have done something wrong. Why do you think that is? Well, it's bigger than the hypotenuse, so that larger than the hypotenuse, greater than the hypotenuse. So we have to be careful with how we arrange it. Let's try another one. Let's try tan. So again, I've got my angle. Actually, I'm going to get rid of this. I'm going to say this is 4.1 centimeters. And this time we're figuring out, I'm going to write 12 cos 70, actually. Because that's what the exact answer is, 12 cos 70, or cos 70 times 12. It's a bit like saying 12 lots of A. So I've got 12 cos 70 here, and I'm trying to find out what my length BC is. Okay, now let's think if I know. Here are quite a few ways to do it. We can use sine, but another way we can do is using tan, and I'm going to show you how. So if I have my angle, just getting my pointer. If I have my angle here, what's the relationship between x and the angle? It's the adjacent, isn't it? I'm just going to put adjacent here. And what's the relationship between BC and the angle? It's my opposite. So let's see how this all plays out. So I'm going to say tan 70 is equal to opposite over adjacent. And what's opposite over adjacent? Well, opposite in this case is x, or BC, and my adjacent, I'm just going to put 12 cos 70, and I'm going to show you a trick. So you've got tan 70 equals to 12 cos 70. I'm just going to swap the sides over because I just like it, just neater. You don't have to do this, it's up to you, but I just like having the x's on the left hand side. 12 cos 70. And x is equal to 12 tan 70 cos 70. Now let's see a trick here. What's tan 70 times cos 70? Well, actually, let me show you something. What's sine 70 over cos 70 going to give me, based on the questions we did last session? It's going to give me tan 70, isn't it? I'm just going to put a box around this. What's therefore sine 70 the same as? You might have guessed it, is tan 70 times by cos 70. How does this apply here? Well, we have tan 70 and cos 70, so I'm going to just highlight them just to make it beautiful. So we've got tan 70 and cos 70, and we've got tan 70 and cos 70 here. Okay. Right. What's tan 70 cos 70 the same as? Sine 70. So we have x is equal to 12 sine 70. And what's 12 sine 70 the same as? I'm just going to write it here. 12 sine 70 is the same as 11.3 centimeters to 1 decimal place. Okay, so that's one method. So we know that it's 12 sine 70 on this side, and it's 12 cos 70 on this side. So we're seeing patterns already. So we're seeing, let me highlight. Let me trying to get a highlighter, guys. Sorry. Let me just change to the right color. So in color green. Okay, so we see that this side is 12 cos 70. We're seeing, and this side is 12 sine 70, and this side is 12. We're starting to see some sort of relationships. What can you tell me when you stop the video and figure it out? So opposite is sine 70, and adjacent is cos 70. That's interesting. But let's move on. And I want to show you how I know that this is correct. Show you that there are multiple ways to solve this question. And let's just change to pen. That would help, wouldn't it? And then just change to black. Okay. So we're trying to find out what BC is. Now this time we're going to use the hypotenuse only. So the last time we used adjacent, this time we're going to use hypotenuse. So if we said sine 70 equals opposite over hypotenuse, if I said sine 70, what's opposite over hypotenuse? So it's going to be BC or x. BC we're going to put, I'll put BC just to be clearer because we've already labelled the side x, over hypotenuse is 12. So BC over 12, BC over 12 equals sine 70. Pen's being funny. So BC is equal to 12 sine 70, which is the same answer that we got from before. So multiple ways of solving the same question. Okay, so I just wanted to point out, so I'm going to draw that triangle again. Okay, so where we had 12, we had 70 degrees here, and we had the right angle here. Okay. Now, what was this side equal to? We found that this was equal to 12 sine 70, didn't we? And this side we found this was equal to 12 sine 12 cos 70. What's another way of writing these out? Well, let's have a think about it. If I have the 20 degrees here, let's have a think. So we have the cos becomes, remember that rule? Cos sine theta equals cos 90 minus alpha, and vice versa. Minus theta, I mean. Or sine, or cos theta equals sine minus sine theta, 90 minus theta. Well, let's have a think here. What do you think this is going to be the same as? Be impressive if anybody knows. So it's 12 sine 20. What's this the same as? 12 cos 20. So one man's sine is another man's cos. One man's opposite is another man's adjacent. So if I had a force of say 7 newtons, and I had an angle of 30 degrees, and I'm just going to go across and up, so I get my right angle, and I have horizontal force. So because it's going this way, we're going to have a horizontal force going from A to B, and a vertical going from B to C. Well, so it has a horizontal and vertical effect. What's my AB force? What's this force going to be? Well, if you think about it, it's adjacent. So I'm going to remove 7 cos 30. Okay, and what's this force going to be? The one that's going upwards, BC. That's going to be the same as 7 sine 30. So one is sine, the other was cos, basically. And you can also say that this is 7 cos 60, or 7 sine 60 on this side. I'm just showing you that these relationships, trying to increase your understanding, basically. You don't have to memorize these are just more for... So I guess you can say it's either, so this one is going to be hypotenuse times by cos angle. So adjacent equals hypotenuse times cos angle, and opposite equals to hypotenuse times by the sine angle, sine of the angle. I normally, you can work it out any way you want, really. So if we know, for example, that x equals to hypotenuse times cos of the angle, how do you think we work out hypotenuse? How do you think we work out this? Well, let's have a think about it. If we do hypotenuse times cos of the angle, cos A equals x, then hypotenuse is going to be x divided by cos A. So we're dividing this time. Similarly, if you have sine, so x equals to hyp sine A, then hyp equals to x over sine A. Right? So let's have a look at this problem now. But you can either memorize, you can memorize these rules if you want. X, hyp equals x over sine A, hyp equals x over cos A. We can show how these rules apply, but for most of us, let's just explore the understanding a bit more. So let's find the length of AC here. So we have hypotenuse, we have what's this side? Opposite, and we have the angle. What deals with opposite and hypotenuse is going to be sine. So we know sine 50 equals to opposite over hypotenuse. I'm writing it out so to remind you. and we say that's equal to 30 over x. So sine 50 equals to 30 over x. And I wanted to show you a trick. Okay. Actually, no, let me show you the proper way first. So here's one way you can think about it. If we multiply by x on both sides, what do we get? We get x, so x times sine 50 times by 30 equals to 30. Because what we're doing, I'm just going to show you at the top because I don't want to obstruct my workings. If you do 30 over x times x, that's going to give me boom, boom, 30. Getting rid of the denominator. Okay, what do you think x is therefore equal to? It's going to be the same as 30 over sine 50. And I think in our previous slide we'd said x is equal to, hypotenuse is the same as x over sine A, or opposite over sine A. And I'm just going to put that in red just to show you that we've actually come up with the same finding. So if I just, in colour, I'm just going to put it on red. Opposite over sine A. Just going to put that in brackets just to show you. Let's see what we get when we type that in. What do we get? 30 divided by sine 50. So I always leave the calculator last minute and I get 39.2 centimeters. So I know I've done it correctly because my hypotenuse is greater than my opposite side. And another way to think about it is if your sine of an angle equals opposite over hypotenuse, and the opposite can never be greater than the hypotenuse, so it has to be less than 1. And if you're dividing by any number less than 1, you're getting a larger number as a result. So if I do 30 over 0.5, what's that going to give me? That's going to give me 300 over 5, and that's the same as 60. So that's another way of remembering it or thinking about it. So I'm getting 30 over sine 50. Now I'm going to show you a quick trick. If you like this method, it's up to you, but I thought I'd show a quick trick anyway. So I'm just going to put a line here so we have that out of the way, and we're going to start off at this stage where the sine 50 equals to 30 over x. Okay, now we know that 6 over 3 is equal to 2. So what's 6 over 2 equal to? 3. So do you see that these two numbers are swapped over? So if I had told you that a over b equals c, then a over c is equal to b. So they're number swapping over. Let's see how we can apply it to here. So we can actually swap over the x and the sine 50, so we're left with x equals 30 over sine 50. And what does that give us? 30 divided by sine 50, again we get the same 39.2. So we bypass lots of steps to arrive at the same answer using just an understanding of how division works. Okay, let's try another one. Have we done this one? Let's try another one. So this time the x is here and the 30 is here. So we have adjacent and hypotenuse. What ratio deals with adjacent and a hypotenuse? It's cos. So we write out our formula. So cos 50 equals to adjacent over hypotenuse. So we're left with So then we have cos 50 equals adjacent over hypotenuse, so we're going to put the values in. So cos 50 equals to 30 over hypotenuse is x. What can we do? Again, we said this, we can swap them over, so x equals 30 over cos 50. And what's 30 over cos 50? That's going to give us to 46.7. So again, we know that this is correct because we're getting a bigger answer, greater answer than we intend, than the adjacent side. What's if you think about it again, cos 50 is 0.6, right? 4 or something to 3 decimal places. So if adjacent over hypotenuse, adjacent can never, is always less than 1. I mean, adjacent is always less than the hypotenuse. So it follows that adjacent over hypotenuse must be less than 1. Okay, so if you're dividing by an answer less than 1, you're going to get 46. You're going to get a smaller answer. Okay, now let's try a different one. Let's try this one. So what's the first step as always? Well, we firstly label the side, so we've got opposite over adjacent. And we've got our angle. So we need to write out the ratio. We need to write out tan 50 equals to opposite over adjacent. We have an opposite this time is 30 and adjacent is x. So if we have tan 50 equals to adjacent over 30 over x, what's x equal to? It's going to be the same as 30 over tan 50. And what's 30 divided by tan 50? That's going to be the same as 25.2 centimeters. Okay. Now let's have a think here. So I told you that sine of an angle is always going to be less than 1 because opposite is always less than hypotenuse. And we talked about how cos of an angle is less than 1 because opposite adjacent. This is, by the way, angles less than 90 degrees, which is the content of this course. So adjacent is less than hypotenuse. Let's have a think for tan A. What do you think the result is? What do you think tan A can vary from? So as we saw, in this case, the adjacent was bigger than the hypotenuse, greater than the hypotenuse in length. Well, greater than the opposite in length, sorry, not hypotenuse. Well, let's have a think. If the opposite over adjacent is greater than the adjacent, we're going to get greater than 1. If the adjacent is greater than the opposite, we're going to get less than 1. And then if the opposite over adjacent is equal to 1, what do you think that's is going to equal to 1? Okay, and where's the breaking point? Well, let's have a think here. So where is tan of an angle equal to 1? So it's where the opposite equals to the adjacent. And let's have an example of one. So I'm going to draw a square, A, B, C, D. A, B, C, D. And I'm going to get 1, 1, 1, 1, and I'm going to bisect it. That should be a perfect bisection. So you have a right angle here, right? You have a right angle here. What is this angle going to be? 45 degrees. And that angle here is going to be 45 degrees. Okay? So let's see what we get when we do tan 45. So tan 45 equals to opposite over adjacent. And it's equal to 1 over 1. And it's equal to 1. Okay, so our answer is A is equal to 45. So 45 degrees is the breaking point. And if you don't believe me, type it into your calculator. So tan 45 is equal to 1. That's just something just worth remembering. It's a bit like how sine 60, sine 30 is equal to a half. And cos 60 is equal to a half. This is one worth remembering. Some of you might need to remember these for your exams. What else did I want to explain? Let's find it. What else did I want to explain? No, I think that's it really. So let me draw let's see if we have any more space. We'll draw it here. So if I have sine angle, cos of an angle, tan of an angle, and I have we have our shape, so we have our triangle A, A, A. Okay, so we know that sine angle equals opposite over hypotenuse. We looked at opposite equals hyp sine A. Now you don't need to remember opposite. If you don't need to remember these, but I'm just showing you that these relationships exist again. Hyp sine A, and we said that cos A is equal to adjacent over hypotenuse. And it's therefore adjacent is equal to hyp cos A, hyp multiplied by cos A. And then we said for tan A is equal to opposite over adjacent. So then opposite is equal to adjacent times tan A. How did we get to hypotenuse? Well, hypotenuse is always going to be opposite over sine A. Hypotenuse here is going to be adjacent over cos A. And what's adjacent going to be the same here as? It's going to be the same as opposite over tan A. So if you think about it, we have multiplication. Wait, no, we have multiplication here, and we've got divide functions here. I don't know, I thought this might help in summarizing it. What else did we learn? Well, opposite over hypotenuse, what is that always less than? 1. Okay, so sine angle, always less than 1. We're only dealing with less than 90 degrees, by the way. Cos of an angle, less than 1. And tan of an angle can be less than 1 or It can be less than equal to 1 or greater than equal to 1. What do you think the limit is for tan of an angle? In reality, I think it's in more or less infinity. It can go to infinity and beyond. Great, everybody. Thanks for that. And we'll move in the next session. We're going to look at how to find the angle in a triangle using trigonometry. Thanks, guys. Cheers. Bye.